Hello, my name is Martin Woolley. I work for BlackBerry and I'm a member of the Developer Relations team. Welcome to my video presentation where I'm going to be talking about some work I've been doing with my colleague John Murray, exploring ways in which enterprise mobile computing could exploit and benefit from the emerging field of the Internet of Things, or IoT. Now this week we've been running the BlackBerry Jam Asia event in Hong Kong. You may have been lucky enough to attend, and if you did, you may even have seen John delivering one of several sessions. Whether you attended in person or not though, you can review many of the sessions as videos which you can find in YouTube. The keynote session created quite a buzz, especially the rocking chair tennis demo, an excellent concrete realisation of the sense, understand and adapt mantra of mobile computing that has us completely gripped here at BlackBerry. But I'd like to look at sense, adapt and understand from a completely different perspective, that of mobile computing in the enterprise, and as you'll see as we progress, that of the world of automotive, of cars and other vehicles. So let's start by stepping back and thinking in abstract terms. The diagram on this slide gives us one way of visualizing the key players in an enterprise Internet of Things scenario and their relationships. On the left we have things, objects equipped with sensors which transmit data to a nearby mobile computing device of some sort. Perhaps this device is in a vehicle, or maybe it's collecting data in a building. An enterprise might be interested in collecting data from all sorts of different entities. Vehicles and buildings are just two. What about their personnel themselves, or the infrastructure they own or maintain? Collecting data from sensors and using it in some local and directly connected computing device can be very useful. Of this I have no doubt. But for an enterprise, the real value may only come when data is transmitted to the cloud, where it is further aggregated, augmented with information from other sources, analysed and exploited. The abstract is all well and good, but what about the concrete? Well, John and I got together to discuss and brainstorm Internet of Things and enterprise mobile computing, and we asked ourselves some key questions. What might the use cases be? How would we actually realise an Internet of Things enterprise solution? Well, this video presentation and the associated blog post, which you'll find at devblog.blackberry.com, are the consequence of the work John and I did together on this subject. Now, for concrete solutions, we need technology. Or to be more precise, we need technologies. There are many different technologies which are associated with or could be useful in Internet of Things scenarios. Three of the key ones, which BlackBerry 10 supports and which John and I have some knowledge of, are here on the slide. Bluetooth Smart, also known as Bluetooth Low Energy, is an excellent vehicle for small amounts of data transmitted by devices equipped with sensors. In fact, it was designed precisely for this. Near-field communications, or NFC, and other RFID technologies may also be used to allow devices to communicate with other devices. And Wi-Fi Direct is another excellent technology for device-to-device communication over a wider area. These could be considered amongst the key technologies supporting Internet of Things. Collecting data from sensor-equipped devices using Bluetooth Smart, NFC or Wi-Fi Direct is something we could talk about in some detail. In fact, we've already published numerous articles, videos and applications on these subjects. So the part that occupied John and I the most when we were considering these ideas was how we might connect the enterprise to all of that data via the intermediate mobile computing devices that were collecting data from our sensor devices. We knew that individual pieces of data from sensors would normally be quite small, but they're considered across, say, a large fleet of vehicles, and over an extended period of time would amount to a very large number of transmissions of data. We also knew that the networks available for the transportation of that data to the enterprise would vary in quality and available bandwidth, and that latency and reliability might be issues too. After discussing and researching, we hit upon an excellent looking candidate for this problem: MQTT. MQTT stands for Message Queuing Telemetry Transport, and it's a communications protocol originally invented by IBM, but which is now an open protocol, and it's a standard governed by the OASIS standards body. It's designed for precisely these kinds of issues, looked a very good fit for the kind of things that John and I were considering, and it's proven. It's used by Facebook's instant messaging system, for example. John and I decided it could be interesting and useful to focus our work on a more specific area, and decided that something to do with cars, vans, trucks, that kind of thing might bear fruit. We were thinking about enterprises that operate large fleets of vehicles, and set about researching the kind of technology cars might have in them today, and the R&D work the automotive industry is apparently engaged in. And we also did some brainstorming. The first question we asked ourselves was this one: what sensors, systems and data might we find in a car today or in the near future? We did some research, and this is what we came up with. All manner of things, it turned out. Some of the sensors we found out about are concerned specifically with the vehicle itself, so things like tyre pressure sensors actually inside the tyres of the vehicle, which use Bluetooth to emit details of the current pressure of a tyre. Through to the vehicle speed itself and transmission speed and the speed with which certain components rotate. But there are also things that were more concerned with the driver than the car. So we found that one or two of the vehicle manufacturers are embedding heart rate monitors in the seats of the car, so that the driver's heart rate can be measured and monitored. We also found that stress measuring devices were being embedded in steering wheels, at least in R&D labs, not necessarily in commercially available vehicles today. Beyond devices and sensors that were concerned with the vehicle and the driver, there were those that were concerned with the way the car was being driven. So there are things called collision mitigation systems, there are things called long-range radar sensors, and these are concerned with things like safety margins. How far away from the vehicle in front are we? So vehicles of today and tomorrow are and will be full of all sorts of amazing technology. We went on to ask ourselves a second question in a kind of part 2 of our brainstorm. What might we do with the data these devices, systems and sensors collect? Well, one of the areas that we were inspired to think of a little more was to do with driving style and patterns. And we had a kind of premise driving this thought process, and the premise was this: corporate enterprises, especially those that operate large fleets of vehicles, like their drivers to be good drivers, because of course bad driving damages their reputation and brand, and very bad driving causes accidents. So we thought about that, and we noted that collection of data from the whole fleet of vehicles over time might enable identification of drivers who need some feedback or perhaps some training. We looked at the collision mitigation systems and LRRS and so on, the kind of data that they presumably accrue, and we thought about location aware data, data relating to weather, for example. And we asked ourselves, could we determine through analysis of data collected and aggregated over time and from many vehicles anything about drivers who are consistently driving too close to other vehicles? Could we draw any conclusions about drivers who do or don't make adjustments in their driving style according to weather conditions? We also, of course, noted we could probably keep an eye on basic vehicle maintenance requirements and how well they were being attended to. Things like tyre pressures would be easy to monitor and collect centrally. And of course, on the other side of the coin, we could find those drivers who consistently drive well, and we could reward them and motivate them. And we might notice through analysis of data from the whole fleet patterns that might indicate vehicle issues, or simply the need for a bigger training program for the whole fleet of drivers. Our second premise around which we did some thinking was this: we thought about corporate enterprises and the duty of care they have towards their staff. And a healthy and alert driver is, of course, a good and safe driver. So we know there are devices in cars or coming to cars which are concerned with the driver rather than the vehicle, and we conceived of a system that would be able to collect driver personal health and well-being data and perhaps act upon any immediate danger signs regarding the driver's health, as well as look at and utilise any conclusions reached about medium and long-term patterns related to health. So things like stress levels, heart rate and glucose levels could be factors in something like that. And we saw, in our mind's eye if you like, an in-vehicle information system displaying warnings and other notifications to the driver on a specially designed in-vehicle console running BlackBerry 10. We thought further and we thought that, well, we could probably augment the data with wearable devices that the driver might have. And certainly on the server side, within the enterprise, we could augment that data further still with a corporate database of employee information containing things like their age and disclosed health issues, whether they're a diabetic or not, what allergies they have, and so on. So, having brainstormed and collected our thoughts on what kinds of things we thought might be the possibilities around Internet of Things and the enterprise, we thought we'd take things one step further and decided to conceive of and explore a more focused scenario. And it looks like this pictorially. So what we have here is in the car a BlackBerry 10 based device of some sort, mounted perhaps in the dashboard, which is displaying information to the driver about the driver themselves, about the driver's driving, and about the vehicle. And we could imagine that this data collected from sensors all around the vehicle and the driver, aggregated and utilised on that BlackBerry 10 device, would then be transmitted over MQTT or published, to use the MQTT term, to an enterprise system in the cloud where data would be analysed and exploited. So, having come up with our concept and our ideas, we thought we'd try and implement this. So we built a proof of concept MQTT API. MQTT was clearly something that we'd probably want to use in multiple applications, so rather than embed that in one application, we built a library. We took that library and built an application called Test MQTT, which just allowed us to exercise the API via that library implementation, and you can see some screenshots of it there. I'll actually demonstrate it shortly. We went one step further. We implemented our concepts application as a demonstration of the concept. Now, to be clear, almost everything on the screen you can see here is hard-coded. It's images to show you the idea, with one exception. The heart rate data, which is on the top left-hand corner of the screen, is real. It's picking up that data live from a heart rate monitor attached to the driver over Bluetooth. It's using Bluetooth Smart, Bluetooth Low Energy. And we also publish that data using MQTT to the cloud. And this application and Test MQTT and the MQTT library, you'll find that in our GitHub repository, so you can take that code, you can play around with it and come up with your own concepts and your own fully working applications. So without further ado, why don't we take a look at the application in action. So I'm starting off with a still image of my demo setup, just so I can talk you through what we have here. Now at the top of the screen you can just see part of my Mosquito server running on my PC, and we'll see messages logged there whenever activity occurs. At the bottom of the screen we have a BlackBerry Z30 running the concept application. That's going to be publishing heart rate data to the MQTT server and receiving that data over Bluetooth from my monitor around my chest. And on the right we have the Test MQTT client application, which will receive heart rate data from the server. Now, let's start the server running. There you go, it's running and listening on port 1883. And now let's start the concept application on the Z30. Now this will connect to the Mosquito server, There we go. Then connect over Bluetooth to the heart rate monitor around my chest and display in real time my current heartbeat rate. There we go, 54 beats per minute at present. Now it's up to 61, and we can see it's actually publishing heart rate data over MQTT to the Mosquito server, and that's being logged on my PC. This is the MQTT test client. Now I need to change the topic that we're subscribing to. And now if I subscribe to this topic name, you can just see the subscribe message on the server. Continue to see messages from the concept application published to that topic name, test HRM rate. And look at the activity log on the MQTT test client, and we can see that it is receiving those messages because it has subscribed to that topic name. So we're collecting heart rate data over Bluetooth from a heart rate monitor. We're publishing that to the MQTT Mosquito server and receiving it on the test client because we have subscribed to that topic. So I hope you found this video presentation interesting and is giving you some food for thought. MQTT looks an excellent protocol for this kind of scenario. BlackBerry 10 is really well equipped with the kinds of technologies that you'd need if you want to deliver solutions that participate in and make use of the Internet of Things, particularly in an enterprise scenario. Now I'll leave you with a few resource pointers. We've published lots of things on Bluetooth and on NFC in the past, and there's a landing page for each of those technologies, and you'll find work published by myself and John listed in those pages, deep dive knowledge base articles, video presentations and open source code. And most of that code you'll find in fact in our GitHub Cascades community samples repository. Finally, if you'd like to follow us on Twitter, John and I tweet about this kind of stuff from time to time, and we'll certainly endeavour to keep you up to date with things that we're doing. And of course, if you wish to make contact through Twitter, ask questions or just have a chat, that would be great too. Thanks once again for listening. We're done.